Hello students, welcome back to another video on waves. In the last video I was discussing different types of waves. I mentioned that light is the same thing as an electromagnetic wave. Today's video is going to be pretty short. I'm just going to talk a little bit more about light and how it's different from other waves, which we call mechanical waves. So in that list of different types of waves that I made in the last video, you might notice that all of the waves I talked about other than light require a medium to travel through. So I'm going to define mechanical waves as waves that require a medium. Okay, so mechanical waves can be a variety of different waves. Ocean waves, sound waves, spring waves. All of these waves require a medium to travel through. On the other hand, light or electromagnetic waves do not require a medium and they can travel through empty space. In the last video I briefly discussed what an electromagnetic wave is and how it is structured. And to summarize, electromagnetic waves consist of an electric field that fluctuates at the same time as a magnetic field. We'll learn more about electricity and magnetism in a future unit, so I don't want to confuse you too much right now with how electric fields and magnetic fields work. But in short, electric fields are generated by moving charges. Changes in an electric field induce a change in a magnetic field, and the change in a magnetic field induces a change in the electric field as well. So as these electric fields and magnetic fields change, they continue to induce each other, which allows this wave to work together to self-propagate eternally pretty much until it collides with something that stops it. We don't need to worry too much about those details right now, but I do want to get into the different types of light and the way that we classify light using the electromagnetic spectrum. Okay, so light, like any other wave, has a frequency and a wavelength associated with it. The wavelength is characterized by the length of one wave, which we can measure from crest to crest, or trough to trough. The frequency of the wave is characterized by how many cycles of the wave happen in 1 second. Okay, we know that light travels at the speed of light. It doesn't matter what frequency or what wavelength that light is, all light will travel at the speed of light. A light wave that has a large wavelength will have fewer cycles travel in 1 second, just because of the size of the wave. Anyways, to characterize light and to classify light as different things based on the frequencies and wavelengths, we use the electromagnetic spectrum, and I'm going to go ahead and just draw it out for you and I'll explain. Okay, so here I've drawn out the electromagnetic spectrum, and I'm just going to go ahead and explain what's going on here. Whenever light has very large wavelengths and small frequencies, we call these waves radio waves. There are many practical applications for radio waves, as you know. We can send signals on top of radio waves and shoot them through the air from device to device, and we can communicate with radio waves. The next type of wave after that is microwaves. These have slightly smaller wavelengths and slightly larger frequencies than radio waves. And a lot of us use microwave ovens to heat things up, so these are also very practical. As the frequency goes up more, the next section that we identify for light is infrared light. Some animals can see in infrared light. Infrared goggles are also a thing. Infrared light is the frequency of light in which heat is oftentimes transferred through. The next section of light is actually a very tiny sliver that we call the visible light spectrum. And the reason we call it visible light is because this is the kind of light that we can actually see as humans. So in reality, there's a lot of light that we cannot even see. The visible light spectrum ranges from red to violet and everything in between. Red is going to be on the left end here. It's going to have a bigger wavelength and smaller frequency. And then after red comes orange, then yellow, green, blue, and violet. And violet is going to be a larger frequency and a smaller wavelength. After the visible light spectrum comes the ultraviolet light, and this is even higher frequencies and smaller wavelengths. This is the kind of light that is notorious for giving us sunburns. Okay, as the light spectrum goes into even higher frequencies, we get into X-rays. As these frequencies get bigger and the wavelengths get smaller, these waves can start to penetrate smaller and smaller things, which is why ultraviolet light can get in our skin. X-rays can go all the way through and then penetrate to our bones, and that's why we use X-rays in the medical field to look at bones. Lastly, the largest frequency and smallest wavelength light that we classify with the spectrum is gamma waves. These have even more penetrative power than X-rays, and they're actually very dangerous because of that, and they can do a lot of damage to us, so we don't have a lot of practical use for gamma rays really. In conclusion, all of these different types of waves are all electromagnetic waves. And electromagnetic waves are all light, so all these types of waves are light waves, just at different frequencies and wavelengths. Okay, so none of these waves require a medium. whereas mechanical waves, which is every other type of wave, do require a medium. Okay, so that's it for today's video, guys. We'll be talking about light a bit more next week. Hope this video finds you well. Hope to catch you next time. Thank you.